Now, CDs were developed in the early 1980s by Sony and Philips to store digital music. A while after they were introduced for music purposes, CD technology was adapted to store digital computer data. And it was great because CDs are inexpensive to produce, and for the time in which they were implemented, they had a large capacity. Remember, we're talking about 1994, 1995, when the first CD drives for PCs were introduced. And back then, we were talking about 20 megabyte hard drives, 40 megabyte hard drives. And then all of a sudden, you attach this device to your PC and you suddenly have 650 megabytes of storage. We had no idea what to do with all that space. Now, let's take a look at the specs of a typical CD disc. A CD is designed to hold 74 minutes of audio. That same specification was carried over to PCs. However, now when you go to the store to buy, for instance, a recordable blank CD, you'll see that you can buy them in either 74 minutes or 80 minutes as well. A CD is 120 millimeters in diameter, and it is also 1.2 millimeters thick. In today's PC, there are 3 different types of CD optical media drives used: CD-ROMs, CD-Rs, and CD-RWs. Let's take a look at each one of these, beginning with CD-ROMs. If you were to look very closely at the bottom of a CD, and you can't see them with the naked eye, but on the bottom of the CD are a series of what are called pits and lands. These pits and lands are used to store binary 0 and 1 data. In general, the way it works is that a pit on the surface of the CD, a pit doesn't reflect, while a land, flat spot, does reflect. If we were to focus a laser beam then on an area of the CD with its pits and with its lands, some parts of it would reflect light, other parts of it wouldn't. By doing that, we can read binary information from the CD, zeros and ones. Here's how it works. We have our CD disc right here. We're looking at it from the end, edge on, so it looks flat. And we have a laser right here. This laser shines its beam continuously onto the bottom surface of the CD-ROM. If it hits a pit that doesn't reflect, nothing is reflected back. If it hits a land that is reflective, however, we get a reflection. And by spinning this disc and moving this laser head around on the disc, we can read binary information. The reflection is captured by a photosensitive device down here, which then converts the pulse of laser light into zeros, ones, zeros, and so on, the binary PC data we need in order to be able to process the information off the disk. In this way, a CD can store binary digital data. In fact, a CD can store approximately 650 megabytes of data, although there are varieties you can purchase at the store that store 700 megabytes. It's important to understand, however, that those pits and lands are etched into the bottom of that CD at the factory. You can't add any data to it. You can only read data from it. CD-ROM stands for Compact Disc Read Only Memory. Now with that, we need to talk about the different types of CD-ROMs. CD-ROMs come in a variety of different formats. The first one that we use all the time is called ISO 9660. This is the standard for formatting data on a disk that will be used for binary PC data. In addition, we also have CD-DA. DA stands for digital audio. This is the standard used to create audio CDs. There's another older standard that's pretty much obsolete now, but it was popular for a while in the mid to late 1990s, called CD-I. CD-I was a standard that allowed you to play back audio and video from a CD. It was really the hot thing for about a year, and then it just kind of dropped off the face of the planet. The last one we want to talk about is CD-ROM XA. CD-ROM XA is a standard that allows images or video to be loaded with audio simultaneously on the disk. Before we move on to CDR disks, we need to talk about CD-ROM speeds. Now, the first CD-ROM drives transfer data at a rate of 150 kilobits per second. That's not real fast. This 150 kilobit data rate was the same speed that's used by your audio CD player. However, for PCs, it was a hair on the slow side. Successive improvements in CD-ROM drive speeds were measured as multiples of this original speed. To calculate an estimate of your CD-ROM drive's transfer rate, simply multiply its speed by 150 kilobytes. For example, a 1x drive transfers data at 150 kilobytes per second. A 2x drive would transfer data at 300 kilobytes per second. A 4x drive would transfer data at 600 kilobytes per second. If we have a modern CD drive, say a 52x CD-ROM drive, then it transfers data at 7,800 kilobytes per second. With that, we now need to talk about CDR drives. A CDR is cool. A CDR allows you to both read from a traditional CD-ROM as well as from CDR disks, but it also allows you to write to a CDR disk, which we call burning. Now, CDRs can only be written to one time. After that, the CDR disk works like a typical CD-ROM drive. Let's take a look at how a CDR works. A CDR stores binary data just like a CD-ROM, but it doesn't use pits and lands. Instead, the bottom of a CDR disk is coated with a photoreactive dye. Now, a CDR has a read laser just like a regular CD-ROM drive does. However, it also has a second high-power write laser. When the write laser hits the photoreactive dye on the bottom of the CDR disk, it changes the pigment to a darker color. In essence, it creates a pit just like on a CD-ROM disk. It doesn't reflect. Anywhere where this laser hasn't hit reflects, and it acts like a land. Using this system of dark and light spots, reflective and non-reflective spots created by the photoreactive dye, a CDR can store about 650 megabytes of data, just like a CD-ROM. As I've mentioned earlier, you can also purchase CDR disks that store quite a bit more, 700 megabytes. Just like a CD-ROM, CDR drives are rated according to their speed. However, instead of having just one parameter, we have two. We have the write speed, and then we have the read speed. Both of these parameters are multiples of the original 150 kilobyte per second speed of a 1x CD-ROM drive. For example, if we had a CDR drive that was rated 2x8, 2x8, that indicates that that drive can write data at 300 kilobytes per second, and it can read data at 1,200 kilobytes per second. If we had a 10x32 CDR drive, that means we can write data at 1,500 kilobytes per second and read data at 4,800 kilobytes per second. Now, CDRs are great and they're a lot of fun. However, they have one glaring limitation. You can only write to them once. That's where CDRWs come in. Now, a CDRW is like a CDR in that it can be written to, unlike a CD-ROM. However, CDRWs can be written to over and over and over. They can be written to, erased, written to, and erased. Like a CDR, they have a capacity of about 650 megabytes. And really what it's like is having a removable hard drive, because you can put it in, write data to it, take it out, put a different disk in, bring it back, erase data off of it, write more data to it, etc. Let's take a look at how a CDRW drive works. A CDRW drive stores binary PC data just like a CD-ROM or a CDR. However, the way it does it is a little bit different. The bottom surface of a CDRW drive is coated with a photoreactive crystalline coating. Just like a CDR drive, a CDRW drive has a second high-power write laser. When this laser hits the bottom of this photoreactive material on the bottom of the CDRW disk, it causes crystals to form. Sometimes this is called phase shifting or a phase shifting media. Wherever a crystal is formed on the bottom of the CD-RW disk, it's like a land on a CD-ROM disk in that it reflects light. The cool thing about CD-RW drives is that they will burn CD-RW disks, and it'll erase them as well. It will also burn a CD-R disk, and it will also read a typical CD-ROM disk. When CD-RWs were introduced several years ago, the earliest models had some weaknesses. One of the key problems was the fact that a burned CD-RW disk that you burned in a CD-RW drive a lot of times couldn't be read in a typical CD-ROM drive. However, for the most part, newer CD-ROM drives can now read a CD-RW disk as well. Now, just like CD-R drives, a CD-RW drive also has a speed rating. And like a CD-R drive, it has a write speed and a read speed, but it also has a CD-RW write speed. So it has 3 parameters. Again, all of these are multiples of the original 150 kilobytes per second 1x speed defined by the first CD-ROM drives. For example, if you had a 8x4x32 CD-RW drive, that meant that it could write as a CD-R at 1,200 kilobytes per second. It could write to a CD-RW disk at 600 kilobytes per second, and it could read at 4,800 kilobytes per second.